Okay? So we are going to be working with that, which means we are going to be plotting points, we are going to be doing graphs just like we did before, but they're going to be different now based on the fact that we have a different type of equation. Okay? So when dealing with exponential functions, it comes in a general form. Okay? And the general form is kind of what you saw. It's y equals a b to the x. Okay? And b, the value b, is what we call the base. And that's where we're used to seeing the exponent. We're used to seeing like x squared or x in general. But now our exponent, or our variable, is actually going to be the exponent. So we're going to call the value in front of it the base. Okay? And it's always going to be a positive number. Okay, where b is going to be greater than 0. Okay? The exponent is the value x, and it's what we call the independent, meaning that y is dependent on what x is. Like your y value will be determined by what your x is, but x can be anything. Okay, so x is the independent variable. Okay, we have domain again that we're going to be talking about, and domain is going to be all real numbers again. So all real. Okay, so basically your x is going to equal negative infinity to infinity. Okay, remember x is your domain is your x values. Okay? So there isn't any x value we can't use. Okay? So it's kind of like the generals of it. So what we just did, you guys, is you actually took this expression, the 4x y equals 4 to the x power, and you actually graphed it. So what we did, and it's kind of hard to read this is 4 to the x right here. Alright. So we just rewrote this so that we would actually see what it looked like. And then we plugged it into our calculator. Okay? And then we got a value for y, and when we got the value, it was like 0.016, 0.063, 0.25, 1, 4, and 16. If you guys wanted those in fractions, you can keep in fractions. It's just harder, I think, harder to graph. Like, it's harder to tell where 1/64 is on a chart. So when we graphed it, it looked something like this. It was like -3 was here, it's like way low here, -2 was like there, -1 was like there, and then 0 was 1, which was there, and then 1 was 4, which was like there, and then 2, which was 16, which is way off. And so it is a line, it's continuous, it's a function, so it goes straight up, and you want to connect it with arrows. Okay? Hence the word smooth curve, right? So you can see that there's a little bit different in the curve. And you're going to see curves that look like this, that go up like this. You're going to see curves that go down like this. You can see curves that go like that, excuse me, and you can see curves that go like this. So you're going to see all different types of ways that you can do this curve, but the point being it's going to be a curve like that. Okay? Does that make sense? Alright, so what we're going to talk about today is then just how to graph them. Looking at what's there and then how to plot it. Okay? As much as the expression we did, the 4 to the x power, was a very simple expression, they can get more complicated, but it's something you've seen before in regards to what each item is, and that you can then use it that way. Okay? So, we have two types of behavior that we're going to talk about. One is called exponential growth, and one is called exponential decay. When you're talking about exponential growth on your expression of y equals a b to the x, okay, b is going to be greater than 1. So if I have b that's like 2, 4, 8, whatever, it's greater than 1, I'm going to have what's called exponential growth, and my curve is going to look like this. Okay? If I have it where b is between 0 and 1, so 0 and 1, I'm going to have what's called decay, and it's going to go like that. Okay? And I think we're used to seeing that with slope. Can you see it okay? Yeah. I think we're used to seeing this with slope. If you have a positive slope, it goes up, right? And if you have, we call it a negative, but this is a less than 1 slope, it goes down. So it's the same type of concept. Okay? So on this graph here, Okay, this represents where the B is between 1 and 0, and that's decay. And this one represents where B is greater than 1, and that's growth. So you can actually just look at a graph and be able to tell if it's growth or decay. Okay? Good so far? Flip. Okay, so we just kind of talked about the growth and decay, and this kind of reiterates it on these two lines here. So if, again, it's greater than 1, it's going to be growth. If it's less, it's between 0 and 1, not just less than 1, but between 0 and 1, it's going to be decay. Okay, and note A is positive in both these situations. We'll look at when it's opposite. Okay, and then what did I say the domain was again? All real numbers, you got it. All real numbers. Okay, so that's kind of the way that we put it, all real. Meaning that x equals negative infinity to infinity. Any x value will work, meaning you have any x exponent, okay? Alright, so there's this thing called an asymptote, and I don't know if you guys noticed it on the graph, but when I graphed it, if you noticed, okay, it went like this, and it got very, very close to the x-axis right here, didn't it? But it never is going to cross it, okay? And the asymptote is going to be the horizontal line that the graph approaches but never crosses. Okay, so it's coming right here, right? And it's never going to actually cross that line. Okay, and we call that the horizontal asymptote. And that is in this one right here, where it's this equation. Okay, y is going to equal 0. Okay, so when you have this situation where it's just a, b to the x, your asymptote is going to be the x-axis here. Okay, so we talk about range, which is my y values. What can my y values be in this situation? Are there any y values that go below this line? Do I have any y values? No, I don't. So my range is always going to be the asymptote and then up or down, depending which way my line grows. Okay, at this point, it's going to be y is going to be greater than 0. It will never be equal to 0, because if it does, it means it actually touches that line, but it never is going to touch that line. It will just become a number that's so infinite small, but it's never going to cross the x-axis. Okay, so our asymptote is going to be that at y equals 0, and then your range is always going to be the value greater than that line, or less than if you're going down. Okay. All right, and then our y-intercept is going to be 0, a in this situation. Okay, when it's just x, it's going to be 0, a. So whatever my a value is, and how that works is as follows. Let's say it's y equals a b to the 0 power, right? Because when x is 0, it's where it crosses the y-intercept, right? So if b is 0, what does b equal? What does anything to the 0 power equal? 1. So this actually then equals y times a times 1, right? Which is just y equals a. So your y-intercept is going to be because remember, it's when x is 0. Okay? Don't forget that. A lot of times you guys forget that. Okay? Don't worry about end behavior right now.
Okay. Not right now.
Okay. Right, because b to the 0 power is 1. Is that better? It's a times 1, because b to the 0 is 1, and then so that just equals a. Okay? Alright, so that's just some general terminology. So we'll look at numbers, and we're going to show you then how we can expand on it, okay? So looking at these two examples here, we identify if it's growth or decay and what the y-intercept is, okay? So I'm looking for what value to determine if it's growth or decay. What am I looking for? So I have y equals ab to the x. All right, what is my a value here? 3. What is my b value? 4. What number or letter am I looking to see if it's growth or decay? B. B needs to be what to be growth? Right. So B is bigger. Is B greater than 1 here? Right. So therefore it is growth. Okay, because B is greater than 1. Okay. What is my y-intercept? Y-intercept is going to be 0, comma a. So what is my y-intercept? It is 3. So 0, comma 3. Does that make sense? Alright, so now let's look at B. Is it growth or decay? It is decay because B is between 0 and 1. Okay, so if you want to do this, A equals 11 and B equals 0.75. Okay, and then what's my y-intercept? 0, comma 11, because that's 0A. Okay, again, remember your y-intercept is when x equals 0. So I plug in 0 for x. The 0.75 to the 0 power is 1. 1 times 11 is 11. So when x is 0, y is 11. Does that make sense? Okay. All right. Bless you. So, as much as I'd love everything to be as simple as this, it's not. We branch off, just like we did with the parabolas. Okay? Do you remember how we branched off in the parabolas and all the other variables we added to it? Do you remember?
No, not really.
Well, one of them is A. What's the other one? Think of our text form. H and K. Oh my gosh, you guys get to see those again. A, H, and K come back. They don't leave you, ever. Okay. So, when you're dealing with an exponential function, you guys, this is the parent function. So when I have y equals b over x, okay, the most complex function is y equals a, okay, b to the x minus h plus k. Okay, does that look kind of familiar? A little bit, right? So notice now, instead of this being in parentheses and being squared like the parabola, notice how the exponent can have an h value, subtracting it. And at the very end you can have a plus k. So, we have the similarities with all this. If we don't see them, then they are either 0 or 1, right? So on this one, where I don't see an a, h, or k, what is a? What is a on this one? On the parent function, what's the value of a? Nope. 1. So on the parent function, a is 1. On the parent function, what is h? Do I see it? No, so therefore, what's its value? 0. And then on the parent function, do I see k? No, so what is k? 0. So on the parent function, you guys, a is 1, h is 0, k is 0. Okay, that's the parent function. Okay? Your line is, your a value on the parabola did what for us? What did our a do for us on the parabola? What are two things the a value told us? If it was up or down, right? So if a was positive, it faced up, right? And if a was negative, it faced down, right? Well, the same situation is here. If a is positive, it's going to be going up, and if a is negative, it's going to be going down. What else did the a value do for us for the parabola? Yeah, if it was wider or narrower. So same thing here. The A is going to make it, depending on the value, is going to make it a longer, like stretchier curve, or it's going to make it a straight up curve, okay? So the stretch is going to be our A value. So it's going to stretch, it's going to, if it's greater than 1, it's going to be a bigger, like wider stretch. If it's smaller than 1, so it's between 0 and 1, it's going to be more spiky. Okay? Does that make sense? Question. Right. So now that we looked at A and how it works, so notice then if I have an A, okay, we're back to where we were with that one function. Okay? Again, this is the parent one, so this is where we start with, and then we know that A is 1, H is 0, K is 0. Okay? So now when we add the other items to it, oh, and then the reflection I forgot to mention. If A is negative, okay, then you're going to have it where it reflects, meaning if it goes like this and then A is negative, it's going to go like that. It's going to reflect, okay? And if A goes like, if it's like this, then reflection would be like that, okay? So the A being negative, this is 0, you can't really see that. If A is negative, then it reflects, okay? So just like with the parabola, okay, it acts the same as with quadratics, right? So the behavior is the same with the A. All right, then we have our translations, okay? So our H did something in the parabola, and our K did something in the parabola, okay? Our H always deals with the X, doesn't it? The H has always been the X value, which means it's a horizontal transition. So it's going to actually shift, it left and right, okay? And then the K, so that's the H, the K is going to shift it up and down. So that's the same type of behavior as well, okay? And so, but the H, the different, and again, it's minus H, so it's the same opposite, right? How it always was opposite, the same situation, okay? But the H, notice, is on the exponent. So H is on exponent, okay? And the K is added or subtracted after you've done everything else, okay? So this is an add-on. Add-on after, okay? And so the full version of the equation is the y equals a b times x minus h plus k. And so it's the same type of format that we've seen with absolute value and with the quadratics. Okay? So by now, hopefully you know the a comes first, and then the h is always attached to the k, or the x, and then the k is added on later. Okay? So that kind of gives you how it all works. Okay? So when we talked about the asymptote up here, the horizontal asymptote, what's gonna change here is that your horizontal asymptote, I can never spell this right, is now going to be the value of what k is. So whatever k is, that's your asymptote. So notice how up here, what did I say k was? Like when we talked down here, what was k? It was 0, right? So if I have a k, then that becomes my asymptote because that's the one that moves me vertically up and down. Okay? Want to try an example? Okay, flip. I'm going to look at the bottom one here first. Oh, now let's look at the top. I'll look at the top one. Okay. All right, so when you get these equations, or these expressions, you guys, I would always break them up and say what my A, B, H, and K values are. Okay? So, looking at this expression, y equals negative 0.5 times 5 to the x. What is my A value? Negative 0.5. What is my B value? 5. What's my H value? 0. And then what's my K value? 0. Okay? Alright. So looking at that, my parent function is going to be y equals 5 to the x. That's, again, parent function is going to be y equals b to the x. Okay, I guarantee you guys, gentlemen, that that's a test question. you need to be able to look at these and pull out the parent function. Okay? Does everyone get what I mean by the parent function? Okay. Is this one a growth or decay? So is B greater than 1 or between 0 and 1? Is B greater than 1 or is B between 0 and 1? It's greater than 1, so it's growth. Okay? Is it reflected? Meaning, is A positive or is A negative? It is negative, therefore it is reflected. Okay, reflected is if A is negative, it's going to be flipped. Right? What's my asymptote? It is y equals k, and what is k? 0, so y is 0. That's my asymptote. Okay? What's my y-intercept? Y equals a, so therefore, what is my asymptote? Okay, so y equals negative 0.5. The y-intercept, meaning it's going to cross this line at negative 0.5, which is like right there. Does that make sense? Okay? Alright, so now you have to do points. So this is where you have to do this thing. Sorry. Can't get away from it. So x and y, I'm going to do the negative 0.5, and then I'll put 5 to the x. So the order of operations is as follows. Okay? You want to do the x minus h first, and then raise your b to that, multiply it by a, and then add or subtract k. Okay? So there is no h, so I just want to do the x to the 5 first, and then I'll multiply by the negative 0.5. So let's do values of, let's do negative 1, 0, and 1, and 2. Okay, 5, so this is going to be negative 0.5, and it'll be 5 to the negative 1. Does anyone have a calculator to do that? An answer? It's negative. Anyone get something?
Negative 0.1.
It is negative 0.1. Okay? 5 to the, this would be negative 0.5, 5 to the 0. That's just going to be a negative 0.5. Because 5 to the 0 is 1. 1 times the negative 0.5 is 0.5. Then I have negative 0.5, 5 to the 1 power. So 5 times the negative 0.5 gives me negative 2.5. And then I have negative 0.5 and 5 squared. So again, I do the 5 squared first, which gives me 25 times the negative 0.5. I'm going to get a negative 12.5. Okay? So then, I'm going to plot this. So negative 1 is going to be a negative 0.1, so it's like right there. I have a 0 and a negative 0.5, so that's like there. I have a 1 and a negative 2.5, which is about right there. And then I have a 2 and a 12, so which is like right there. Oops, 2, right there. Okay? So I have my few points. What's my asymptote? We said y is 0, right? So therefore it's never going to actually cross that line. It's just going to get infinitely close. So all my points just come really, really close, and I can just do an arrow like that. And then I connect all my other dots and just draw it down like that. Does that make sense? Okay. Again, we're not doing end behavior right now, so don't worry about end behavior. Okay, domain. What's my domain again? All real. Alright, so negative infinity to infinity, x equals. Alright, what's my range? So, I will never cross what axis? I will never cross the x-axis. I'll never cross. So my asymptote is 0. So y is going to have something related to 0. So this is always going to be your asymptote. Asymptote.
But that can change.
No, the value that y is will always be your asymptote.
Right.
But 0 can be a different number. Yes, your asymptote does not always mean, is not always going to be 0.
When we get into this later, aren't we able to cross the
No.
x-axis? And
Yeah, you can cross the, yeah, your asymptote can change. It may not always be 0. It's actually going to be your K value. So it's always going to be K.
So we can like, cross the X but not the Y sometimes? What is that called?
Not in this situation.
Well, we can at some point.
So, is Y greater than or less than that value? It's less than. So Y will be less than 0. So, because all my Y values are below that asymptote, so again, your range is always going to be Y and K, but you have to determine if it's less than or equal than. It all depends on which way your graph is. See how my graph is going below? That means it's less than that value. So all my X values will give me Y's that are less than 0. Does that make sense? Yes? Alright. So, questions on what we just did? Alright, so let's look at this example right here. What is A in this example? A will not be 0. It is 1. Okay, what is B in this example? 4. What is H in this example? -2. Remember, it's the opposite of that right there? Okay? Does that make sense? What is K in this example? 0. So just so we know that K is 0, what do we know about anything else on here? Yeah, we know the asymptote, right? So Y is going to equal 0 for the asymptote. We know that right away, because Y equals K. Alright, is it growth or decay? It is growth, because B is greater than 1. Is it reflected? It is no, because A is positive.
So it is positive, it's not reflected?
Correct. If A is negative, so see how this one it like flipped down? Because A is negative. If A it was positive, it would flip up. Okay? Alright, what's my y-intercept? Now this one's a little bit trickier, because we have a H here. So basically our is going to be when x equals 0. So when x equals 0, what's the y value? So I plug in this, 4, 0 plus 2, that equals 4 squared. What does that equal? 16. So when x is 0, y is 16. So that's our y-intercept. So when you have an H, it changes that. Okay? Alright, so then we want to do some points. Alright, let's do x and y. Alright, let's do -2, -1, 0, and 1. Okay, so it's going to be 4x plus 2 here. So when I rewrite this, I'll do 4 minus 2 plus 2. So you do the exponents first, so it's -2 plus 2, what does that equal? 0. 4 to the 0 power is 1. Then I do 4, and I have -1 plus 2. You guys see that? Okay. So what is -1 plus 2? 1. 1. 4 to the 1 power is what? 4. If I do 4 and I have 0 plus 2, so that's 4 squared, what does that equal? 16. And then I have 4, 1 plus 2, so that's 4 to the 3rd power, and what does that equal?
64.
64. So are you seeing how I'm plugging in the values of x to where x is? Okay. Alright, so now I have some points I can plot. Okay, so if I go and I plot these, I'm going to have -2, 1. I'm going to have -1, 4. I'm going to have 0, 16, which is like way up here. Okay, so it looks like my graph is going to look something like this. Okay, does that make sense? It's not really accurate because 0 would be 16. That's way up there. So, all right, what's my domain?
All real.
Yay! What's my range? It's going to be y and k. So we know that's going to be y and 0. So is it greater than or less than that value? It's greater than, because it's all above. See, all the y values that you encounter are above 0, right? So those values are greater than. Does that make sense? Okay? Questions on that? Alright, so let me just go back. Let's just go over it real quick. Alright, so we talked about the general form. Your b is your base, and your x is your exponent, okay? Your x is your independent, your domain is always going to be all real. Your y's are going to be your asymptote. Your range is going to be your asymptote. You have it where it's growing or decaying based on your b value. Okay? And then we talked about all the translations here. We have the a, b, and then parentheses x minus h plus k, where we have all those translations where a does something for us, h does something for us, and k does something for us. On your parent function, you guys need to know the parent function. Star it. Okay? A is 1, H is 0, K is 0. And then all your translations will change what those values are. Okay? Good?